Okay, this is Coach High again. This is 7.1b and 8.1a prerequisite for understanding the number line, understanding real numbers. I'm going to go through this. I hope you can see it. This is an analogy referring to the number line, how it works, and we're going to discuss some things here. The number line. There's some things on the number line that I'm going to point out. One is the brown that you see right here. This represents land. Okay, the blue right here looks like the sky. So what you're looking at is the sky. These gray little white things here, those are clouds. And this blue right here, this represents water, like the ocean. This part right here, this is like what they call sea level. If you all pay attention in your math class, in your science class, your earth science class that you took, I think in 7th grade, or you're probably taking it where they talk about sea level, and this represents the origin or zero on the number line. Okay. Each point, or this is the number line. I don't want to get ahead of myself. The red represents the actual number line, and each point on the number line, represents a whole number. Each point, including zero. Zero is a whole number. Okay, so you should be filling in this part right here where I'm pointing at. It says each point represents a whole number. That's what you should have, and these are the points on the number line. Okay, now when we talk about the whole numbers, you're going to be filling in the boxes. So the first box to the right, it is the number 1. If you notice that the land is also rising, so the land, the number is getting bigger, as well as the value of the land is getting larger. There's going to be more land, and it's getting higher and higher. So the numbers are representing the value of the land. Okay, so you got 1, 2, 3, and 4, and then you have a sign here. This sign is called the infinity sign. It means that it goes on forever and ever and ever and ever. That's a big number, but that's also why we have scientific notation. That will be for another lesson. We also have above that, you also have above the number 1, you have a box, and in that box is square root of 1. You remember your Darth Vader square root chance. Square root of 1 equals 1. So it's the same thing as 1. Square root of 1 is a rational number. It is not a irrational number. Okay? The irrational numbers are on top of the clouds because they do not fit on the number line. Okay, remember the 3 parts that we talked about? Well, actually, you will cover that tomorrow in one of the stations. You have phi. Phi is represented as 1.618, and it goes on forever and ever and ever. The Greek letter phi right here. You have square root of 2, square root of 3. These are irrational numbers because their decimals go on forever and ever. So you can't place him on the number line. You can't place him on the number line. Okay. Square root of 5 is after the square root of 4, which is equal to 2. So it's not on the actual number line. It's like a cloud. It is above the land. Okay. You also have E. E represents for Euler's number, and Euler's number is used in a lot of physics applications, like atom bombs and stuff like that. That number is 2.71828. Okay, and then you have the 3 and square root of 9. So square root of 9 equals 3. Okay, so we know that square root of 9 is the same as 3. So square root of 9 is a whole number. It is a rational number. Up above it, though, you have also, almost up above it, a little bit to the right, is 3.14, or pi. 3.14, that decimal goes on forever and ever and ever and ever. So that is not a rational number. It is an irrational number. And if you notice, it sits a little bit over right of the 3. Okay, so we was at pi. Pi is a irrational number that's in the clouds. Pi is normally used for circles. It's the number for the circle of a circumference of a circle. Excuse me. Once again, we have number 4, and then we have 16. Square root of 16. The square root of 16 equals 4. Okay, so all of the positive numbers, if you notice, the positive numbers are on this side, and the negative numbers are on this side. Now, this is the most important part. You've got to understand that the larger the number, the greater the value from 0. The larger the number, the greater the value from 0. So the farther away to the right of the 0, or the origin, the value gets larger, and you can tell that by the land. The land is getting larger. Okay. Now, negative numbers, the larger the number, the smaller the value from 0. Why? Because the farther to the left that you go, the land is decreasing. So there's more water. So if you was to walk down,
59 has arrived. 59.
Sorry about that. We're having a crunch. I'm trying to get these in. So the farther down that you go, you're gonna have to be a pretty good swimmer. Okay, because you might be seeing the hammerheads and the great white sharks and the big whales. Okay, so the farther down, it means the less land there is and the more water there is. Okay, and this means you have less land when you pass below the sea level. You have less land to pass below sea level. Okay, so don't forget, fill out the blanks. This is negative numbers. This is positive numbers. Negative numbers are to the left of 0. To the left of 0. Now we will use this tomorrow when doing integers. Thank you. Oh yes, please make sure that you fill it out. Thank you.